Welcome back, focused learners. Today, we're cracking open the ultimate strategy guide, the examiner's playbook for the Cambridge Computer Science 9618 syllabus. We are diving deep into a really crucial section, the social, economic, and environmental impacts of artificial intelligence. We're going to decode the core principles, the tactical methodologies, and some absolutely critical warnings pulled straight from the principal examiner reports. So, let's get right into it.
Now, you might be wondering, why focus heavily on this one specific area? Well, check this out. The AI impacts topic actually accounts for roughly 15% of your total marks in Paper 2. 15%. That is a massive chunk of your overall grade resting on just this single topic. So yeah, your time investment today is incredibly valid. This isn't just some minor subtopic that you can quickly skim over the night before. No way. This is a heavy hitter. This is exactly where the top-tier candidates separate themselves from the rest of the pack. So mastering this 15%, that's your strategic advantage.
Okay, here's our roadmap for today's session. First, core principles. Second, the method mark strategy. Third, algorithm quality evaluation. And finally, number 4, the top 3 examiner warnings. Let's move.
Section 1, core principles. And specifically, why analytical depth always wins over superficial breadth.
So there's a really stark contrast between what students think works on this exam and what actually works. On one hand, you have superficial breadth. Some candidates just overload their answers with raw facts. They literally list everything they've ever memorized about AI, but without any real analysis. But here's the kicker. The assessment framework actively punishes that kind of surface-level knowledge. Instead, it heavily rewards logical, structured, and evidence-based reasoning. That's your analytical depth. You can't just list facts. You have to explain the how and the why. Honestly, this depth is the fundamental difference between an average response and a truly top-tier one.
And here is another major leap for your strategy, making cross-topic connections. This is a massive insight we pulled directly from the principal examiner reports. You see, the conceptual framework for computer science doesn't just exist in a vacuum. It's like a giant puzzle. When you can connect, say, the environmental impacts of training an AI model to the specific hardware architectures you studied way earlier in the syllabus, or when you link economic impacts to data privacy protocols, well, that's when the magic happens. You're demonstrating the exact systematic analysis that examiners are desperately hunting for.
Section 2. The method mark strategy. This is all about securing points through procedural frameworks.
Okay, understanding this method mark strategy is absolutely crucial. Basically, it means earning exam points by explicitly showing your systematic process and your clear working, rather than just jumping straight to a final conclusion. The examiners literally want to see your brain on the page. In a lot of these complex AI impact questions, the journey to the answer is actually where the real marks are hiding out. If you rush and you just throw down a final thought without showing the procedural steps that got you there, you are leaving so many easy points on the table.
So, let's look at a standardized sequence to make sure you get those marks. Step 1, identify the key elements of the scenario. Step 2, apply the relevant AI principles. Step 3, execute your analysis with very clear working. And Step 4, verify your results. Think of this as your tangible go-to checklist. When you're staring down a complex past paper problem, don't panic. Just break it down using this exact 4-step framework. Identify, apply, execute, verify. By standardizing how you approach these, you're going to ensure you never miss a procedural mark again.
And by the way, this same kind of procedural framework applies directly to your practical programming skills too. The methodology basically mirrors itself. First, design algorithms. Second, implement your solutions. Third, test them thoroughly. And fourth, evaluate the performance. This structure is essential, not just for coding, but for critical data interpretation. For instance, if you're extracting data from binary representations of AI systems, doing calculations, and drawing conclusions, you've got to follow a methodical sequence. The examiners are grading your process just as much as your final solution.
Section 3, algorithm quality evaluation. Let's talk about thinking like a top-scoring candidate.
When you are evaluating algorithm quality in AI systems, you have to pinpoint exact metrics. You need to explicitly connect time complexity to its direct effect on execution speed. You have to link space complexity right back to its impact on memory usage, and crucially, you have to identify edge cases and explain how they impact overall system stability. It is not enough to just name-drop a fancy term like time complexity. You actually have to analytically evaluate its real-world effect on how the model performs.
So what does this evaluative thinking actually look like on your exam paper? Well, top-scoring candidates show very specific traits. First, they consider multiple solutions. They don't just stop at the first idea that pops into their head. Second, they analyze trade-offs. Maybe an algorithm is incredibly fast, but it eats up a massive amount of memory. You have to point that out. Third, they explicitly acknowledge the limitations of whatever system they're proposing. And finally, they justify all their decisions with concrete evidence. If you integrate these 4 traits, you are literally writing exactly the way an examiner thinks.
Section 4, Top 3 Examiner Warnings. Let's make sure you avoid the ultimate point traps.
All right, these are the most common candidate mistakes, and this is pulled right from the official data. We're talking about forgetting to check overflow cases, missing crucial edge cases, and completely ignoring boundary conditions. Look, students will often build a really great logical argument, but then they entirely forget to test the extremes of their AI scenario. And just like that, they lose easy marks. You have to actively hunt for the boundaries of the problem you're solving.
But honestly, the absolute biggest trap is this examiner alert right here. Let me read this to you verbatim. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. I literally cannot emphasize this enough. You could write a beautiful, technically flawless paragraph about the environmental impacts of AI, but if you fail to link it to the specific company or the exact scenario provided in the prompt, you will not get the marks. It's that simple.
Let's contrast this so it's crystal clear. On one side, you have generic, memorized answers. This is the student who panics and just dumps everything they know about AI onto the page hoping something sticks. That is a losing strategy. On the other side, you have points strictly linked to the given scenario. That's the winning strategy. That's where you apply that analytical depth we talked about earlier. Every single point you make must explicitly reference the context given in the exam.
All right, let's lock all of this in. We've covered analytical depth over breadth, the 4-step method mark strategy, algorithm evaluation metrics, and those critical examiner warnings. So here is my final challenge to you. What is your unique mnemonic using the first letters of these key terms to lock this strategy into your memory for exam day? Take a second, create your memory hack right now, apply these frameworks to your very next past paper, and just watch your understanding deepen. Keep learning, keep pushing, and keep applying that analytical depth.